ratios, and then we're going to learn how to apply these to word problems. So let's look at this triangle. We're not going to use actual lengths of sides, but we are going to use the letters A, B, and C to talk about the lengths of sides. What, if we were to do that, what letter would we use to represent the hypotenuse whenever we're dealing with a right triangle? We learned this when we learned about the Pythagorean theorem.
It is the longest line.
And what letter do we use to represent it? A, B, or C?
A.
It is the longest line. It's always the longest line. It's always the letter C. The letter C is always the length of our hypotenuse, if we don't know the actual number. All right, we know that A and B are our legs, and C is our hypotenuse based on the formula A squared plus B squared equals C squared. So let me know if you know which of these line segments, either CV or AC, which one is going to be little a or leg A.
Line CB.
Right, line CB is across from angle A, therefore we call that line little a. So our leg A is across from angle A, so obviously our leg B is going to be across from angle B. And this is how these triangles are set up, how we set up our right triangles in general. And we saw that with Pythagorean theorem, we're seeing this with trigonometry. Who can tell us that little saying that we learned that helps us remember what sine, cosine, and tangent are equal to?
SOHCAHTOA.
SOHCAHTOA. Good. SOHCAHTOA, 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 whatever helps you remember. So what does sine equal? Give me the words. What does sine equal?
Opposite over hypotenuse.
Opposite over hypotenuse. So sine equals opposite over hypotenuse. Use SOH in our little saying to help us remember that. What does cosine equal? Grant?
Adjacent over hypotenuse.
Adjacent over hypotenuse. And what does tangent equal? Raymond?
Opposite over adjacent.
Tangent equals opposite over adjacent. So that's where TOA comes from. Tangent is opposite over adjacent. Okay, so what would the ratio be for sine of A in this picture?
A over C.
A over C. Decide opposite angle A over the hypotenuse. Good. What would sine of B look like as a ratio? Bela?
B over C.
Right. B over C, which is the side opposite angle B over the hypotenuse. What would the cosine of A angle A equal?
B over C.
Right. The adjacent side B over the hypotenuse C. What would the cosine of B equal, Kay?
A over C.
Right, the opposite side A over the hypotenuse C. What would the tangent of angle A equal, Andrew?
A over B.
Right, it would be the opposite side A over the adjacent side B. And what would the tangent of B look like, Mel?
B over A.
Right. It would be the opposite side B over the adjacent side A. So yesterday we came up with this. Sine equals opposite over hypotenuse, and we could write that as A over C. Cosine equals adjacent over hypotenuse, and that's B over C if we're referring to angle A. Important that we always keep in mind what angle we're referring to. And tangent is opposite over adjacent, which would be A over B. So we can see a pattern here that sine always starts with opposite, cosine is adjacent, and you can take the opposite and the adjacent and put them together, and that gives you tangent, opposite over adjacent. Sine and cosine have hypotenuse as the denominator. There's no hypotenuse in your tangent. You're not dealing with the hypotenuse at all when you're dealing with the tangent. Yeah, and you can also see with sine A is in the top, with cosine B is in the bottom, and if you put the A over the B, that gives you tangent. There's a couple of patterns there. On this first word problem, we're going to start, I want you to notice that when you're working with the right triangle, if you're going to use trigonometry in order to solve your right triangle, the way you recognize it is that you don't know 2 out of 3 sides. If you knew 2 out of 3 sides of the right triangle, you just use the Pythagorean theorem to find the third side. But when you're dealing with trig, the way you know to deal with trig is you're dealing with 2 sides and an angle that's not your right angle. It's one of the acute angles of your right triangle. With the Pythagorean theorem, we were dealing with the fact that it was a right triangle and the 3 sides. With the trigonometry, we're dealing with the fact it's a right triangle, one of the acute angles and 2 of the sides. And your x will be in one of those 3 positions. So your x is either going to be one of the lengths of the sides, or it's going to be one of your acute angles. Your x falls in one of those 3 positions. Okay? That's how you can tell the difference. All right, so let's start out here. What I usually do when I'm setting these problems up is I write my degree down first with a little room to write in the function in front of it once I figure out what that function is. Now, in this case, we're looking for the length of the leg. It represents the height of the tree. And we know the length of the leg that is the distance from the tree to some point out here. Let's say that this is where someone's eye is, or where someone's standing and they're looking up at the top of the tree. And the angle that we have from the person to the top of the tree is 30 degrees. So I'm going to draw a little person right here, just to make this feel a little realistic. So we have a person looking up at the top of the tree, and there's a 40-degree angle from the person to the top of the tree, and the person's standing 50 meters from the tree. So we have x and 50. Can anybody tell me what function we might be dealing with here with x and 50?
Would it be the that be?
When I say what function, your answer will be sine, cosine, or
Oh.
tangent.
Is it going to be sine because it's the
Are we dealing with the hypotenuse?
tangent?
Tangent. Yes, it's going to be tangent, and it's not going to be sine or cosine because we're not dealing with the hypotenuse. There's no information about the hypotenuse, and x is not where the hypotenuse is. You always want to put your x in so you can see all the sides we're dealing with. We're dealing with the 2 legs, which means it's tangent, and then a degree of 40 degrees. All right, so what's our fraction going to be if we write down opposite over adjacent? We've got x and 50 to work with. So what's our fraction going to be?
X over 50.
X over 50. X is across from 40 degrees and 50 is adjacent. So this is opposite over adjacent. Good. All right, now, what I want you guys to understand is what it means to write down tan of 40 degrees. So I'm not going to show you how to solve this equation right this second. I'm going to do a side step to help you understand what we're doing and why we're doing it. Okay? So I'm going to come over here to the side, and I'm going to write down tan of 40 degrees, and I'm going to show you guys how to put this into your calculator. This is actually going to give us a decimal. So on your calculator, what I want you to do, all right, so you're going to press on your calculator the second button, and then go down to where it says PRB, and right above PRB it'll say trig in yellow, so you want to hit that button. Then you're going to hit your arrow button. So there's 4 arrow buttons. You want to hit the one that points over towards the right, hit that 4 times, and then hit enter. When you do, you'll see tan on your screen. Then you type in 40 for 40 degrees, and then hit enter again, and you'll get 0.83 ... and we rounded that to 0.84, so we can see tan of 40 degrees equals 0.84. 0.84 is the decimal that tan of 40 degrees means. Now I'm going to pick this up on the next video.